Okay, hello everybody. My name is Jake Kurth, and welcome to another one of Leeds Helpful Tips live streams. As I just slipped up a little bit, do know that these streams are absolutely live. And what we've been doing is a series of informational, hopefully helpful tips and tricks that we've learned from our customers or that we've worked on over the years to help you guys use our microscopes and use our equipment for forensic purposes. So today's live stream is going to be all about how to do stage measurement on our LCF series comparison microscope, like the one you see behind me, as well as our Discovery series microscopes, specifically the manual systems. The motorized system, if you'll look through our live stream list, I recommend checking it out. I actually did a live stream, maybe about 3 or 4 weeks ago on the stages, and in that live stream I kind of go through how to do measurement on that system. But today is all about our manual systems with the LCD scale. So a couple things before we begin. It is a live stream, so sometimes things do happen. If they do, bear with me. We'll get through it. We'll come back to live. And also, as a quick note, you can always, if you have a Google account and you log into YouTube, or if you're comfortable doing that, there's a chat window, and you can just type in any questions you have. And as I see those questions, I will go ahead and respond to them, and I'll try to be monitoring and making sure there's enough time to answer those questions. So yeah, without further ado, let's jump into it. So what we have been doing over the years is Leeds has been putting a digital caliper, basically, like a Mitsatoyo caliper, on our left side of our microscope. And the reason we do that is because we noticed a lot of our customers, basically all of our forensic customers, were needing to do land and groove measurements. And they're trying to do it quickly and efficiently. And so historically, the way people have often done these land and groove measurements is they will either use like a separate tool, a measuring device, like an encoded measuring device or a caliper sometimes. Or what they'll do is they'll actually project through the comparison scope a known measurement standard. Maybe it's a glass slide with some rulings on it, or maybe it's like some gauge blocks. But yeah, so what they'll do is they'll place your bullet here, you'll place your measuring reference here, and then you'll try to project through and then get a rough estimate of the land or groove width impression. And that's a fine way to do it. But the problem is that no matter which way you're doing it, whether you're doing it on a separate device that you have off to the side of your microscope, or whether you're projecting that image through that air gap method, you need to stop your comparison, set something up, try to do it that way, and then go back to doing comparison. So what we did in our comparison scope is we actually placed, like I mentioned, this digital scale directly on the scope. And Leeds had been doing NIST traceability on the scale for a very long time. And then when we started to see that ISO was coming out, we then became actually an ISO calibration facility. So now we can have a NIST traceable standard for any measurements you make with the scale, but also it's to ISO. So what do we do and how do we do it? Well, it's really easy. And I'm going to show you. So really quick, let's see if I can get this set up correctly. What I'm going to do is just kind of switch over my view. And maybe actually before I do that, I'll give you a brief overview of what we're going to do here. So our comparison microscope, it has that digital scale on the left-hand side, but we also equip it with a crosshair. And so the idea here is that if you have one of these binoculars, we actually call this one a binocular as opposed to more commonly what we're selling now is a tilting trinocular. So what you would do on the binocular is replace your focusing eyepiece with your crosshair eyepiece. If you have the tilting trinocular, you can actually put the crosshair eyepiece in either eye, whichever one you prefer. And then what we're going to do is, and now this is the part where I'm going to switch over, is we're going to line up that crosshair on the start of our land or our land impression or the start of our groove impression. And that crosshair is going to give us a reference. And what's neat about that is we're actually, instead of using an air gap method or trying to estimate, what we're doing by using our scale and with the crosshair as the optical reference, we're actually measuring the stage travel when we do this measurement. And so what that gives us is a very accurate measurement that's very reproducible. And in fact, this is a very similar method to what they use in tool makers' microscopes, is that they're actually using an encoder and they're actually measuring the stage travel. And so we use that same method for all the benefits of measuring stage position versus trying to gauge an estimate based on a ruling or something like that. So yeah, to switch over, I'm going to show you kind of what once your crosshair is loaded and you're looking through the microscope, we're going to switch over. And this is kind of what you're going to see. You're going to see a crosshair in the middle of your field of view. The crosshair orientation doesn't matter. So let's say the eyepiece, you put it in and it was rotated. So instead of being this nice, perfectly centered crosshair that you have in this picture on your screen, let's say instead it was more like an X. So it's just rotated. That's totally fine. You can, if you want to, just kind of rotate the whole eyepiece and you'll get it set up. But you can also use this measurement technique without actually having the crosshair perfectly perpendicular. So then what you do is you're going to line up that crosshair, you're going to move your stage, and you can see as my stage is moving, you maybe understand the gist of where I'm going with this. We're going to put the start of that crosshair on the start of our land impression, and that's what we're looking at right here. As a quick point, the higher magnification, generally this methodology and all measuring methodology is going to be less accurate at low magnification. You're going to have greater accuracy at your higher magnification. And in this process, the reason your accuracy increases is because it's a lot easier to pick and reproduce exactly where you're starting with your measurement and where you're ending with your measurement. So right now I'm at about 14x. So then what we're going to do is I'm just going to use my stage control. We're going to line up on the start of my land impression. The really technical part happens now. I'm going to hit the 0 button on my scale. That's it. So it zeroes out the scale. And now what's going to happen is the stage or the scale is going to measure total position change. So now when I move to the opposite side of my land impression and stop, the stage is measuring that change in position. If I overshoot, that's okay, and I can come back. It won't cause an issue with my measurement. And so what I see by doing that measurement is I started the land impression, went to the end of my land impression, and I get a 0.750 inches. The scale you can always flip it to metric, so that's 191 millimeters. I think millimeters. I'm pretty sure it's millimeters. Wouldn't be centimeters. Yeah, it's millimeters. So yeah, so that's the whole idea, is you just zero it, move across, and measure. Just to show you guys again, maybe what I'll do is just zoom in. We can redo that, and we'll just get a good view. I don't know how clear this is going to be, but you can see that there are some buttons there. Maybe I'll turn this down a little bit. So just to read to what I already did before, is I'm going to go ahead and look at my bullet. I'm looking through the eyepieces. This is my stage control. I'm going to go ahead and start on the start of my land impression, where I want to pick my start. Maybe I'll go ahead and zoom in a little bit more. I'm going to bring the image into focus using my focus control. I'm going to go ahead and zero the scale, and I'm going to measure to the opposite side. And I can adjust my focus so I can pick exactly where I want to go. And there I get 0.760, and I'm looking right here at the scale. Oop, you can't see that. I'm looking right here. Here we go. I'm looking right here at the scale. And so that's essentially what you do. Just to give you a reference of what everything looks like when you're using it, what the isocert looks like. This is an example of one of our isocerts. And what we do is we do a series of test measurements. I just scroll down. We do a series of test measurements and what it is measured and what it actually is measured. And so this is the ISO certificate that comes with our comparison microscope. And we also, as you can see, have uncertainty of measurement here too. The idea with this method is that you can do very quick land and groove measurements. You just zero the scale, move to the opposite side, and that gives you your measurement. Just line up that crosshair. So that's it for today. Thanks for watching. One of our helpful tips. If you have any suggestions, any other videos you'd like to see, anything that you'd like us to further explain about any of our products, be it our Leeds spectral vision system, our comparison scopes, Evo Finder, for example, please feel free to email me at jkurth@leedsmicro.com. And until then, thanks for watching.